And welcome back. Now in this one we are going to use K-fold cross validation for the purpose of balancing the data. So this is not the only purpose of K-fold cross validation. It is used for model selection also and for data balancing as well, right? So here we are going to utilize this in the context of balancing our imbalanced data. So if I have to tell you what exactly the cross validation is, so here I'm going to create one demonstration which will help you to understand what exactly the k-fold cross validation is. So consider this red bar is whole set of your data which is containing somewhere 88,213 records, right? This is the whole set of the data that you have. Now in k-fold cross validation what we do is it's nothing, it's simple. When you create a logistic regression, what exactly that you do is you split your data into 70% and in 30%, right? And then you do the testing, correct? You do the you train your model on 70% of the part and you test that on 30% of the part. In cross validation what we do is we split the whole data in n number of segments. That segment is also called fold, right? So for example, here we have this data set 1 and I am splitting that in two parts. One is training set and the test set. So not exactly two part, I am splitting my entire data in 5 segments. Let's say I splitted it in 5 segments. So first 4 segment I'm going to utilize that as training set, and the last set I'm going to utilize as test set, right? So this is how I'm going to utilize in the first iteration, right? This is the first iteration. In second iteration what I will do is, if you see, the fifth set I have included in the training and the fourth set I'm using for test. Same way, in the next iteration what I'm doing is fourth, fifth, first and second, all of these segments or folds I'm using to train my model, and this third set or fold I'm using to test it. So what exactly that is happening over here is in every iteration what happens, a new fold from the training set comes for the testing, and whatever we had in testing set that goes back into the training. So it's kind of cyclical training, right? It is happening, if you see, it is happening in loop in each of the iteration. And that if you do it this way, what happens, your model sees each kind of the data, right? And it trains itself in on all sort of the data. It will have the knowledge of all overall, idea of your whole data, right? And basis on that it would have better understanding. Okay, now once it is done, so that's how it keeps on iterating, and once it is done what we do is the whatever score comes out of it we average that, and that's where we conclude the model or maybe the data balancing. So you see, these were the 3 iteration. In fourth iteration what will happen is second fold is going to be used as test, rest is as training, and so on in fifth fold. So this is what happens in the k-fold cross validation. Nothing much, no rocket science, it's very simple. Okay, now let me take you to the Jupyter notebook and help you understand this over there. So over here, to start with, what you need to do is from sklearn model selection, first of all you need to import this stratified k-fold. Okay, once you are done with this stratified k-fold, then what you need to do is you need to create the instances. So here I'm going to explain about k-fold cross validation. So here I'm going to create one instance, let's call it k-fold equals to this, and into this you need to provide how many split that you want to make. So in ideal split is 5. In our consideration also we are going to keep it 5. If you want you can make it 10, you can make it 3, you can make it 4, whatever you want. So I'm going to keep it 5. Number of split is 5. Then shuffling I'm going to make true. Shuffling I will make true. Then this is done. After that, so because this will be splitted in 5 parts, so it will be a series, or maybe yeah, it will be a number series. You can also consider that just like a list, right? So we would require to iterate through each of the elements. So for that we would require to use for loop. So I'm going to say for train index index and test index, because we have to split this, right? Index in KFold dot split. KFold dot split. So KFold is nothing but this instance, and that using that KFold has a method or function, you can say. Using that, I'm going to split my data in training index and testing index. So to split that, here is what I have, right? Independent and dependent features, right? So let me take this. I will take this only, right? So independent set I'm going to use over here, and then here I'm going to use dependent set. All right, this is done. Then I would require to create xtrain, xtest. For that, what I need to do is I will take, for training data set, I would use independent set of data, and for the testing, the dependent one has to be used. I mean, not exactly what I said is true, right? That is not true. So independent is the whole data set except the target variable, and into this everything is not available. I mean, it has only the target variable available. Okay, so let's split this one first in training and test, right? So what I'm going to do is I will say independent dot ilock, and inside that I'm going to put this one, training index. Same thing I will again do. Oops, sorry, please bear with me. I need to put square bracket over here. Then again I need to use independent data set ilock, and then inside that I'm going to use test index, right? So the set of features which I had, now that is splitted in training and test. Next thing, the target variable also I need to split that. Okay, train y test dependent dot ilock, and inside that again I'm going to use train index, and then I'm going to again create dependent dot ilock, and inside that I'm going to use test index. All right, this is done. Now train test split is done. You are aware, once train test split is done, then what exactly we need to do is we need to fit our model. So to fit our model, here is the logistic regression instance I have already created. Let me show you that. Logistic regression instance I have created over here, right? So let me just make sure that it is initialized. Okay, so that is initialized. Let me go down again, and over here I'm going to say logit dot fit, and inside that I'm going to use my xtrain comma ytrain, right? This is done. Then logit dot predict, and inside that I'm going to use xtest. This I will store in prediction, that is stored into the prediction. Now after that, sorry, I need to say equals to. I will also try to take the score of it, right? And let me say score equals to logit dot score, and inside that I'm going to take xtest comma ytest, and over here prediction. Okay, now after that what I will take is confusion matrix. Okay, confusion matrix, and inside that what I'm going to say is, let me put it into the accuracy, and inside that confusion matrix I need to use prediction, and next one what I will use is ytest, so that I could compare it. Then classification report, I will also use classification report. Now into that let me say classification report, and here I'm going to say classification report. Inside this again prediction and ytest. All right, this is done. Now so what will happen is, because we are going to split the data in 5 segments, right? So every time it will run and it will fit the model on each of the set. It will do the prediction, it will create score, and then it will create the confusion matrix, and this everything, right? So what we exactly need to do is we need to put it in certain storage area, right? So here I'm going to create one thing blank list for score. Into this I'll keep on storing all the scores, right? Then for accuracy, I'm going to just or let me say CM confusion matrix, and that I'm going to use over here. And then classification report I'm going to use over here, right? So once this is done, what I will do is I'll keep on appending them. So I'm going to remove it from here, and I would say append, and let's append it over here. Same way I will take this confusion matrix and I'll put over here, and no requirement to store that in any temporary variable, but here I need to say dot append. All right, now let me just see this class rape again, classification report. This is nothing but the classification report, and here I would say dot append, and again let me just store it. All right, I think we are pretty much sorted. Let's try to execute it. Let's see what happens. Well, that is done. Now let's see what all that we got in scores. All right, so you see here 5 scores we have got: 95, 95, 95, 96. So approximately for each of the fold, that is working pretty well, right? Now let's print the confusion matrix. Confusion matrix, you see this is how it is looking. Now let's see the classification report. Classification report, this I would require to do this thing for I in classification report print I, so that it could look a little better, huh? This is first iteration, second iteration, third, fourth, and fifth. So you see in each of the iteration it is looking pretty good, right? 96% is the accuracy, 78% is the F1 score, right? Here 76% is the F1 score, 76, 76, and 77. So F1 score is in the range of 70, I mean 75 to 80, right? And accuracy is above 90%. So this is what we have got over here. And if you compare it with the previous techniques, I think SMOTE worked pretty well, right? So SMOTE had performed pretty well. In this SMOTE we had got the F1 score of 91%, right? In SMOTE we had got it for 91%, so that worked pretty well. KFold cross validation is also working pretty well. That's not bad. 77 and 76 is pretty good as against to 38 what we were getting in the very beginning. All right, so I hope that it was easy for you to understand KFold cross validation. I highly encourage you to go ahead and try to use it in your practical work, and let me know your experience.